Okay, we're going to be looking at May 2010, paper 2, problem 3. Zone 1. All right, so first one question asks us about chloroethene, C2H3Cl. It's an important organic compound, and it asks us to draw a section containing at least 6 carbon atoms. So you know you're going to have 6 carbon atoms. Okay, and then each one of them kind of in groups of 2 from the ethene is going to have 3 hydrogens and then a chlorine, and this would be the repeating pattern of the polychloroethene. All right, you can have the carbons and hydrogens in alternating spots above or below. You do need this continuation for the point, and there you go. All right, so outline why polymerization is of alkenes is of economic importance and why the disposal of plastics is a problem. You can write plastics are inexpensive. Expensive, geez, or cheap, you can say cheap. Okay, to produce and have many uses. And then the problem with them is that they are not biodegradable. So they take up a lot of space in landfills. So take up a large amount of space in landfills. Geez. Okay, so going on, chloroethene can be converted to ethanol in 2 steps. For each step, deduce an overall equation. Okay, so for the first one, we have to take that, the ethene, react it with hydrogen to make the chloro, or the halogenoalkane. Okay. And then in the next step, we are going to react that halogenoalkane with the hydroxide ion, and that will form the alcohol and the chloride ion. Okay, so the reagents necessary are going to be acidified dichromate ion and under reflux. You need both this for one point, under reflux for the second point. Okay, going on to the next, make it a little bigger. State the equation for the reaction of ethanoic acid and water. So we have we have ethanoic acid and water setting up an equilibrium with the ion and the hydronium ion. aqueous, water's liquid, this would be aqueous. So this is the equilibrium of a weak acid. You do not have to do state symbols, I just do. All right, so calculate the pH of a 0.2 moles per decimeter cubed ethanoic acid with a pKa of 4.76. For me, this is setting up an ice table. So I would have, again, the ethanoic acid and water setting up an equilibrium with that ion and the hydronium ion. Remember, in an ice table, you have to have concentrations. It gives us the concentration of the acid. You assume initially that there is no dissociation of the acid. Remember, pure liquids and solids don't enter into your Ka. The equilibrium, hopefully you see, is going to shift to the product side because there aren't any products yet. So 0.200 minus x, and then I have x and x. We're going to assume that x is small. Remember that Ka is equal to the concentration of the products over the reactant, or reactants, depending on the equilibrium. So this means that your Ka, remember your Ka is going to be 10 to the negative pKa. So Ka is equal to 1.74 times 10 to the negative fifth. So I've got 1.74 times 10 to the negative fifth is going to be equal to x squared over 0.2. Using your calculator, x is equal to 0.00186, which is equal to the hydronium concentration, so the pH is equal to the negative log of that. So negative log of that, and I get a pH of 2.73. Okay. They don't give you a whole lot of work to set up the whole ice table. Ask for extra paper. Okay, so now the next question is to determine the pH of a solution formed by adding 50 centimeters cubed of a 1 molar ethanoic acid to a 50 centimeter cubed of a 0.6 mole per decimeter cubed sodium hydroxide solution. So this is going to set up a buffer because I'm going to be left with acid and its anion in the same solution, right? So first thing we need to do is decide what the concentrations are so I can put them into a ice table. So what you're going to have is the acid plus the sodium hydroxide, if you get the formula right, geez, going to NaA plus water. This is going to be soluble. I'm going to have some of this left. So how many moles of HA do I have? Remember, it's going to be the volume times the molarity, making sure the units are right. So I would have 0.0500 moles of HA. Moles of sodium hydroxide would be my 0.5 times 0.6, so 0.05 times 0.6 gives me 0.0300 moles of my hydroxide ion. So if those two react, I'm going to have 0.0200 moles of HA in solution and 0.0300 moles of the anion. Okay, this would be the ethanoic acid, and this would be the anion from that. All right, I'm just using shorthand. Now remember, in an ice table, I need concentrations, so I'm going to divide these by the total volume, which is 0.1 decimeters cubed. Okay, divide by 0.1 decimeter cubed. All right, setting up my ice table, which would be HA plus H2O in equilibrium with the anion plus the hydronium ion. The concentration of my acid initially is going to be 0.002 molar. I'm not going to worry about water because it doesn't enter in anyway. This is going to be 0.003 molar, and I'm not going to have any hydronium in my initial. Hopefully you can see that it's going to shift again to the products because I don't have any hydronium. So this is going to be minus X. This is going to be plus X plus X. You're going to assume that X is very small. So at equilibrium, that would be my concentrations. Again, setting up Ka. Ka is 1.74 times 10 to the negative fifth, found from the previous problem. That's going to be the reactants times each other over the products. So X, which is equal to the hydronium concentration, is going to be equal to 1.75 to the negative fifth times 2 is 1.16 times 10 to the negative fifth. So pH is negative the log of that number, which gives me 4.94. All right. You do need to show marks for the full 4 points, or work for the 4 points. You have 3 points if you have the correct answer with no work shown. Okay. And then this last question is, explain how the solution formed in part E can act as a buffer. Use equations to support your answer. So if acid is added, the anion is going to react with the acid to form ethanoic acid. Okay, if base is added, your acid is going to react with the base to form the anion and water. Okay, and that will give you the 2 points. And that's the end of this problem.